Attention passengers, this is your conductor speaking. The train is about to leave the station. Please stand clear of the closing doors. Thank you. Welcome to Calayag Train Express. Enjoy your travel! This stop is Transportation Systems Analysis. I repeat, Transportation Systems Analysis. Passengers, this is your tour guide speaking. To understand the concepts related to our first stop, let me guide you through the principles of Transport Systems Analysis introduced by Marvin L. Mannheim. He divided the principles into two groups, the system and the analysis problem. Without further ado, let us start with the principle 1, which says the basic components of a transportation system are the persons and things being transported, the vehicles in which they are conveyed, and the networks through which the vehicles move. Mannheim said the purpose of this principle is to establish what we mean by a transportation system. Relative to this, John Paul Rodriguez defined transportation system in his book, The Geography of Transport Systems. A transport system can be conceptualized as the set of relationships between nodes, networks, and demand. Here we can see a diagram of Rodriguez's definition of a transport system. These relationships involve locations spatially expressing this demand, flows between them, and infrastructures designed to handle and link these flows. Now let us move on to the second principle, which says all movements through the transportation system must be considered. This principle can be related to the four critical dimensions of change in transportation systems as identified by Tom V. Matthew. The dimensions of change are change in the demand, technology, operational policy, and values of the public. These dimensions of change, according to Matthew, can form the background to develop a right perspective when analyzing a transportation system. Mannheim identifies Principle 3 as movements must be considered from their initial origin to their final destination, and Principle 4 as all modes of transportation must be considered. To increase the effectiveness of the transportation system, it is essential to give these principles more attention. Principle 3 focuses on the interface between modes, the interchange nodes and their characteristics. Under Matthew's basic premise of a transportation system, these are all the considerations he listed. The fifth principle says a transportation system is a particular form of market in which supply and demand reach equilibrium within the constraining channels of the transportation network. This principle is in parallel to the prediction of flows, which Matthew identified as the core of the transportation systems analysis. We now arrive to Group B, the analysis problem. The next principle states the spectrum of transportation options potentially available includes decisions about routing and time schedule for a particular trip or shipment, system operations, changes in non-fixed resources and procurement of new equipment, changes in fixed facilities, and introduction of basically new transportation technologies. Through this principle, it is attempted to summarize the range and variety of transportation options open to decision makers in various contexts. Mannheim states that the seventh principle is transportation is not an end in itself. This one emphasizes that the ultimate objective in providing transportation is to fulfill some broader public or private objectives. Principle 8 says there are a variety of transportation-related options available. Particularly important are those which can influence directly or indirectly the demand for transportation. Because transportation is not an end, then transportation decisions must be accomplished in concert with decisions in a variety of transportation-related areas. Last but not the least, the ninth principle according to Mannheim is there is a spectrum of direct and indirect impact of transportation relevant to the choice among alternative systems and policies. In Ben Immer's lecture, he identified models that help determine the impact of the various options, namely demand models, supply models, short-run equilibrium models, long-run equilibrium models, and impact models. The output from any of these models will generate the input for a social cost-benefit analysis. This ends our first stop. Mannheim's principles might just be one of the many basic principles utilized in transportation systems analysis of different countries. However, according to Matthew, the core of these diverse principles is the TSA approach, which is the interaction between the transportation and activity systems of region. This approach is to intervene delicately and deliberately in the complex fabric of society to use transport effectively in coordination with other public and private actions to achieve the goals of that society. This stop is transportation planning. I repeat, transportation planning. Safer, smarter, faster, more convenient. That is the purpose of transportation planning. Passengers, in this final stop, I will be telling you all about transportation planning. According to Plan RVA, transportation planning is the process of looking at the current state of transportation in the region, designing for future transportation needs, and combining all of that with the elements of budgets, goals, and policies. In a report by Japan International Cooperation Agency or JICA, they define transportation planning as a nonlinear process. It should allow for iterations, should be user needs-based, and should be adaptive. UP listed the overall transport planning process as consisted with problem definition, definition of goals, objectives, and criteria, data collection, forecasting, development of alternatives, evaluation, and implementation plan. These elements are similar to JICA's public transport planning process. The only difference is the additional first step, which is the establishment of the study area. The study area may be a corridor within a public transport network or a district within an urban area, whole urban area, province, or region. In defining the goals, objectives, and criteria, JICA recommends the use of SMART planning model. Now, allow me to focus on the element forecasting. According to Korea Transport Database, forecasting is done to predict future transport demand when establishing transport plans within a given budget. The forecast is based on current travel patterns of transport systems and under the assumption that general conditions will not greatly change. Therefore, drastic or detailed changes can result in prediction errors. In the Philippines, there is a lack of consistency with its transportation planning process. One of the things that the country can focus on is the requirement of a traffic impact assessment or TIA. In his article, Ian Fulgar wrote that the TIA enables road authorities to determine whether an existing road network can handle the traffic generated by the proposed development, particularly in the short term. It can also allow the road authorities to create mitigation measures that may resolve anticipated traffic networks. He concluded that the need to identify and prepare countermeasures for the traffic impacts of urban expansion via traffic impact assessment is a momentous step. Despite this, the Philippines still does not legally require submitting a TIA report. According to Fulgar, it can only be imposed to any vertical development if it falls under the three factors identified by the UP National Center for Transportation Studies Incorporated, which are transportation impacts, traffic generation, and parking generation. When designed properly, a transportation planning process can meet the important goals identified by Plan RVA, namely access to employment, freight mobility, safety and security, system reliability, congestion mitigation, environment and air quality, multimodal connectivity, and preservation and maintenance. Attention passengers! This is your conductor speaking. You have now reached the end of your travel. Please be careful as you get off the train. Thank you for trusting and boarding the CTX.